So hello, here we are group B20 and our topic is master slave architecture. So our main functionality in our system is word count, matrix multiplication and battery status or health status. In word count, if there is a very large file and we have to count the frequency of the word in that, then we will divide it into the smaller chunks and send it to the slave, and master will then recollect the smaller chunks and again send the result to the client. And in matrix multiplication, as we are leading to the data mining area, there is a possibility that there will be a very large matrix calculation. So for matrix multiplication, we are dividing the matrix into smaller chunks and then sending it to slave and collecting the cumulative result and sending back to the client. And we are collecting the battery status of all the slave because we want to know every time that if the status is up and running or it is down. So this is our system design we have made. The first is the client. Client will communicate to the server, and server here we have put the two server for the failover handling, that there will be availability between the two servers, that if the first server will fail, then the client will be redirected to the second server. And now the primary server will work as a master and he will make a RPC call to the three slaves. Now master's work is that it will divide the word count work between the three slaves and then collect it back to the master and send it back to the client system. And there is a reliability between the slave. If that is, if one of the slave is down or crashes, then the master will redirect the request to the other slaves and get back the result and send it to the client. Now the our main architecture is the master slave architecture. In that, the master will distribute the subqueries to the slave nodes, and the slave will perform the subtask, and then they will send the result back to the master, and the master have to collect the result and combine it and uh, make it to the view. Now the dividing into the subquery is called the map function, and the collecting and aggregating the result from the slave is called the reduce function for the master. So this is how our architecture works. So now we will go up with the demo.
Hello sir, I am Sahil Mangukiya. Our group is B20 is going to present master slave implementation in distributed system. This laptop is name server. These both two laptops are slaves, and these two laptops are master servers, and this one laptop is client.
Hello sir, I am Chalodiya, and so now I am going to start the name server. So here I have started the name server, and now all the slaves will be able to register themselves to the name server.
So myself is Manan Dankhara, and now I will start the slave. So now the slave is ready for the receiving the commands from the master.
So here is the second slave, and it will also able to register to the name server.
Hello sir, I am Poojan Patel. So now I will show the demo of server. So this server is of primary server and this is secondary server. So let's start the primary server first. So now primary server is started. So now let's start the secondary server. So now secondary server is started. So whenever a client request request a server, then the connection will be first redirect to the main server, primary server, and if the primary server is not working or is crashed, then only connection will be redirected to the secondary server, and the connection between client and server is done using socket, and the communication between server and their master then their slaves will be done using RPC call.
Myself Somin Gandhi. I will be handling the client side. So let's request to the server. As we request to the server, our UI which is made in tick enter will be started. So let's do word count. Here I will be selecting the files for which the word count is need to be done. Now it will request the server.
So as we can see, the request of word count has arrived in the primary server and not in the secondary server. So what server will do is that it will first try to connect with the slaves, and first it will check the battery status and health status. If the client if the server does not receive battery status, then the connection will not be redirected to that server slave. So here first the battery status is checked, and now the slave will be shown, and from here we can see that the slave 1 is closed, and slave 2 and slave 3 are active, so request will be directly redirect to the slave 2 and slave 3.
Here in this slave we have received small chunk of file that the master has sent, and in this slave we have also received small chunk of the file that the master has sent. Now the slave is doing the subtask of counting the frequency for the small chunk that he has received by this getMake function. Now we will see the output in the client side.
As you can see that output has came on the client side, and which is word and its frequency. Now let's do other functionality.
As we know, there are two master server, one is primary and another is secondary. Now we purposefully destroy the primary server, so let's destroy it. And now let's start this slave 1 which was previously closed. So now slave 1 is started, and all the requests of the client will be automatically redirected to the secondary server.
Now we will do the matrix multiplication functionality. Here we need to give the dimension of the first matrix. So let's give 3 cross 3 matrix. Now we need to enter its value. Now we will need to give second matrix and its value. Now we'll submit this. We got the output.
Now as we had closed the master server, primary master server, so all the requests will be redirected to the secondary master server. So now the request came to this secondary server. So first we will check, first server will check that battery status of all the slaves, slave 1, 2, 3, and based on that it will send the response it will divide the matrix and send to respective slaves, and then server will then reduce all the answers and club into one final answer. So we got the final answer in the server.
As you can see that slave 1 is now available. So based on the server round robin fashion, slave 1 have received first row and the second matrix to be calculated.
You can see that slave 2 has received second row of the first matrix and the second matrix.
Here we can see that in slave 3 we have received third row of the first matrix and the second matrix to multiply.
As depicted in our earlier presentation about our architecture, we have successfully implemented reliability server failover for master and slave, and availability for the master servers. And for clients, as we can see, it was completely transparent process as he was not aware about the architecture behind the scene. Thank you for our demo.